mordant in the acid-fast stain. Because what happens, you put the carbofusion in, and it sticks in the mycolic acid waxes. Gram stains, you put the crystal violet in. See, now Cody's got me. Listen. You put the crystal violet in for a gram stain, but you add the mordant to help it stick in the wall. With the acid-fast stain, the mycolic acid wax is already there. They're going to help the carbofusion stick in there. Okie dokie. Remember the difference between anaerobe and aerobe? In your lab quiz this weekend, you'll get questions about that too, because the bacteria that we're looking at in the lab, we want to know, are they anaerobic, aerobic, or facultative anaerobes? Two. Maybe they're aerotolerant anaerobes. Remember what they are like? Okay. So, if the organism requires oxygen for growth, must have O2 to grow, it's an obligate aerobe. If it will be killed by oxygen, it's an obligate anaerobe. Cannot tolerate oxygen. It's obligated to be an, without air. If it's a facultative anaerobe, that means probably lives with air just fine, but if you cut off its air, it's got a backup plan. Facultative means it can also do metabolism without oxygen. Might not grow as well, but at least can survive and get through. Then there's aerotolerant bacteria. They don't use oxygen. They ignore it. They tolerate it. It's there, it won't kill me, but I'm not using it either. Okay? Okay. And don't forget temperature requirements. If the bacteria grow at human body temperature, what do we call
them?
Mesophilic. Mesophilic. Bacteria consider our body temperature the middle temperature range. Meso is middle. So think of yourself, your middle temperature range for bacteria. If it's hotter than the human body, then they could be thermophiles. There might be extreme thermophiles, which would probably be archaeobacteria. Then there's psychrophiles. They like it colder than the human body, but pretty cold, like maybe in your fridge. If it's extreme cold, like the polar ice caps or something, or Antarctica, then those would be extreme psychrophiles. So psychro is like psycho, like it's got an R in it. Psychrophiles like it cold. Thermophiles like it hot. And mesophiles like us. Remember what human body temperature is in
37
degrees F? Good. Don't forget, boiling, freezing, room temperature, body temperature, and maybe even fever temperature. Google it. What temperature?
You want it in Celsius?
Both. You should know both, depending on what your doctor uses it as. If you have a European doctor, he's going to talk Celsius. You have an American doctor, he's probably going to talk Fahrenheit. Also, there's different fevers. Some fevers are low grade, and some fevers are very high grade. So you should know what, if the doctor says he's got a temperature of black, X many degrees C, you should be able to know, is that a high fever or low fever? So that's not on your test. The same one is on your test about body temperature, room temperature, boiling and freezing. But just for your own information, you might want to Google different fevers and what temperatures they are in degrees C and F. Okie dokie. Let's see. How about neutrophiles? What are they like? Neutral pH. Like human body tissue fluid is usually 7 to 7.4. That's kind of neutral. Acidophile likes it more acidy. That's lower numbers. Lower than 7 is acid. Higher than 7 is basic. Basic would be alkalinophiles. They're like a basic pH. In your digestive tract, your stomach, you know that's acid. So name a bacterium that causes ulcers that must like acid pH because it lives in your stomach to cause ulcers. Helicobacter pylori, right? Think of a pyloric ulcer or the pylorus in your stomach. Helicobacter pylori. It's an acidophile because it lives in your stomach where it causes ulcers. Vibrio, by the way, is usually alkalinophilic. And Vibrio cholera lives in an alkaline portion of your bowels. And Vibrio cholera is thought to be transmitted by, guess what, seawater, just like Vibrio vulnificus. And seawater is typically more basic. Okay, you will have questions about the special media that you're working with in lab this week. So you're going to have a lab this week, and then bingo, right away, you have it on the test this weekend. So if you can wait until after Thursday to take your exam, it might be a good idea in your lab quiz too, because Thursday we'll still be working on the material for the test. Okay, you need to know the difference between selective medium and differential medium and enrichment medium. Enrichment medium is enriched with special ingredients. For example, blood agar would be enriched with blood. Chocolate agar is enriched with dried blood. Mannitol salt agar is enriched with salt also. But they can also be selective. Selective promotes the growth of one type of bacteria so that it has an advantage over any other type. It might also inhibit another type of bacteria. But selective means it has special ingredients that select for one type over another type. It helps one type and either leaves the other type alone or hurts it a little bit. What happens is competition. If I help her win the race by giving her a pair of roller skates, but I don't give her anything, she just has to run the race, I'm selecting for her to win because I'm giving her something extra that helps her, and I'm not giving her anything extra. In other cases, your selective agar might be, I give her a pair of roller skates to help her win the race, and her, I take her sneakers away. So she has to run it barefoot, and then she can't run as fast, right? So selective agar could work either way. Help one, but not the other, and let her competition beat her out. Or you might help her and even hurt her a little bit, so she's going to outcompete her for the agar. Differential agar means when a certain type is present, you'll recognize it by a color change. Let's say I have a medium that's differential for her type and not for her type. First of all, I might select so she gets the advantage, but when she grows on the Petri plate, I'm going to see that bright, colorful shirt. I know she's there. I know she made it. I know she grew. I don't see anything about her. She didn't change color of the agar, but she did. When she showed up in those bright colored shirts, I'm like, wow, she really is there. So that's differential. You're going to look for a color change. And sometimes, don't forget, I make up answers. And if the answer sounds like totally unfamiliar, that's probably because it's BS. I made it up because I'm like, I need another option, A, B, C, D, E. I can't think of another thing, so I have to make something up. Sometimes you might get a choice that's something that you don't recognize because we haven't covered it yet. And if you don't recognize it, we haven't covered it, it's probably not the right answer. So go with something that's a little more obvious, something you should be expecting to know. Okay. Okay. What is the most common type of bacterial cell division? What did we call it? Binary fission. Good, binary fission. You might see me call it transverse binary fission, but binary fission is there also. Okay, what happens? Cell copies its nucleoid, elongates by synthesizing extra materials, produces a transverse plate of cell wall material, and splits in half down the middle. So it's binary fission, one parent cell makes two daughter cells. They're genetically identical nucleoids unless what? Mutation. Unless mutation happened in the copying. Good. Okay? When we did the bacterial population growth curve, what do you call the amount of time it takes for cells to replicate? A generation. Generation time. So, if it takes me 20 years to replicate, that's my generation time. What's the replication, how long is the replication, or what's the generation time for E. coli?
20 minutes.
20 minutes, good. And most Staphylococcus is
30.
30 minutes, good. And what's the longest generation time we can think of? Which bacteria has the longest generation time?
Mycoplasma.
Mycobacterium, good. Okie dokie. Don't forget your growth curve. You gotta know your growth curve. What are the phases? What's happening in each phase? And that kind of stuff. So, your growth curve, you'll see one on your test if you get that question, but you just have to memorize the curve in your head, what it looks like. So, you have the log number of cells on one axis, and you have time on the other axis. The first part of your curve can't start at 0. You have to start with some number of cells. However many cells are in your inoculum. You inoculate fresh medium with a certain number of cells. You might not even know how many. And they acclimate to the medium. So the first part of the growth curve is called the lag phase because they're actively metabolizing, but they're still getting used to it. They're not really ready to divide yet. Some might replicate, some might die, but overall, you're going to have no net increase in bacterial numbers. They're acclimated. Then, once they're acclimated, you get the exponential increase part of the curve. That's the log phase, because logarithmic growth and exponential growth is two different terms for the same thing. That's the optimal increase in bacterial numbers. That's the shortest possible generation time. They're doubling, doubling, doubling at an optimal rate because conditions are good. The agar is still fresh and new, or the broth is still fresh and new. It's got plenty of nutrients, plenty of space for new ones to replicate. Not many wastes have accumulated yet because the population is just starting to grow. So the population is going to grow at its very best, have its shortest generation time. That's the healthiest time for the population. So if you're going to transfer your culture over to a new medium, that's when